Some alarming news today for millions who live along the Great Lakes. The Army Corps of Engineers says 3 of the 5 lakes, Michigan, Huron, and Superior, broke January records for water levels.
Something is moving under Lake Michigan, and it is not seasonal ice, not ship traffic, and not anything the Midwest was told to expect. Sensors are picking up cracks in the lake bed that look like the first lines of a split, and the agency that watches quiet ground just raised a red flag. If a stable lake can break, what else that we trust as solid is getting ready to shift? The alert. No one expected. The region around Lake Michigan is supposed to be calm. It sits far from the big fault lines. People build skyscrapers, tunnels, water plants and bridges there because the bedrock is old and steady. That belief is why the alert from the United States Geological Survey shocked local officials. Satellite images, lake floor sonar, and a dense line of underwater sensors all showed the same thing. New fissures were opening in the central basin of the lake, and they were opening faster than normal sediment shifts can explain. These were not small surface cracks from waves or ice. They started deep in the rock. The main fracture stretched for more than 15 miles, according to the first model, and many smaller branches ran out from it like ribs. Some of those branches ran toward the western shore, where millions of people drink, fish, and ship every day. Even stranger was the pattern in the data. Readings taken in March did not match the readings taken a month later. The strain across the lake floor was higher. The cracks were under stress, and the stress was not easing. Micro-quakes that people on land could not feel were shaking the basin every few hours, and those quakes lined up with the fracture map. To the scientists watching, it looked less like erosion and more like a rift system waking up. Rifts are places where the crust pulls apart. They are common in East Africa and under Iceland. They are not supposed to grow under a Great Lake. That was the reason for the red alert. It did not mean an instant disaster. It meant the process under the water was no longer slow enough to ignore. Once a crack forms in rock under that much weight, water and sediment can push into it, widen it, and connect it to other weak spots. Each connection changes pressure across the basin. Change the pressure enough, and the lake bed can heave in some places and sink in others. Engineers who plan water intakes, power tunnels, and ports have to know if the ground under them will stay flat. Suddenly, no one was sure. Local planners were told to treat the lake floor as active terrain, not fixed ground. That alone changed emergency maps overnight. For now, however, field teams sent submersible drones from Milwaukee and Muskegon to see the fractures directly. They filmed long dark slots in the lake floor where sediment had dropped away. Fine bubbles were rising from several of them. Gas tests later showed methane and carbon dioxide, both common in deep rock but unusual in this amount for this lake. Gas release means pathways. Pathways mean new water routes. Put together, the picture was clear. The base of Lake Michigan was changing shape. If the base keeps changing, how long can the waters and the cities around them pretend nothing is truly wrong? The old scar under the lake. To find a cause for the new cracks, geologists looked backward. They went to maps of the Midcontinent Rift, a billion-year-old tear that curves through what is now the Great Lakes. That rift once tried to split North America before it froze in place. Its deep rocks are still different from the crust around them. They are denser, more brittle in some layers, and laced with old magma bodies. Most days, none of that matters, but if weight on the crust changes or if stress from the mantle shifts even a little, those old weak zones can start to move again. Lake Michigan sits right above one of those zones. When ice sheets covered the region, the crust flexed downward. When the ice melted, it rose back up. That rebound is still happening, and new climate patterns have added a twist. Rapid swings in lake level changed the load on the lake bed faster than nature used to do it. Heavy years push down. Dry years let the ground spring up. Rock does not like to bend back and forth. Sometimes it breaks. That is the working theory many teams now share. Ancient rift plus modern rebound plus water load equals fresh fractures. The problem is the scale. The main crack the USGS mapped is longer and deeper than what those gentle forces usually make. It looks more like a structure that wants to link to other faults and form a system. If it becomes a system, pathways will open for water, gas, heat, and possibly even warmer material from deeper crust. Sonar scans already hint at warm spots. Thermal images taken over several weeks showed patches on the lake floor a few degrees hotter than the areas around them. That is not lava. It is most likely fluid moving through rock and carrying heat upward. Every geologist who saw that data wrote the same note. Active. Active is a rare word to see in reports about the interior of North America. It means the rock is changing now, not in some far past. It means measurements taken this month will not match next month. It also means the forces below are not fully mapped. That is why teams in Chicago, Green Bay, and Muskegon began to share data daily. They need to know if a crack under mid-lake could shift stress closer to intake pipes, tunnels, or even to the sand foundations that hold up harbors. A slow tilt of only a few millimeters can change how water flows, how ice forms, and how breakwaters handle storms. Engineers can design for waves. It is harder to design for moving ground. The rift story is clear enough for scientists, but how do you tell the public that a lake floor, once called stable, is now classed as a fault zone that has to be watched? Water, gas, and fragile systems. Once the fissures were confirmed, attention moved from theory to impact. Lake Michigan is not just scenery. It is a water source for Chicago, Milwaukee, and many small towns. It is a shipping route, a fishery, and a thermal sink for power plants. A crack that taps deep rock can change the chemistry of that water. USGS and university labs tested samples from near the largest fracture. They found slightly higher methane, carbon dioxide, and sulfur compounds than normal offshore readings. Those levels were not dangerous yet, but they proved that the lakebed was venting from depth. If venting grows, the water above a fissure can lose oxygen. Fish avoid such zones. If the venting includes metals or hot fluids, treatment plants have to work harder to keep water safe. Most plants were built to stop microbes, not deep earth leaks. At the same time, satellite ground deformation data showed parts of the western shore lifting by millimeters. On their own, such uplifts do not crack roads or break pipes. But over years, combined with lake bottom flexing, they can shift the stress on buried lines and intake tunnels. Engineers along the Chicago to Milwaukee corridor have already been asked to model what happens if the lake floor sags in one sector while the coast rises in another. That kind of uneven motion can pull joints apart or push bridge footings out of alignment. Ports and marinas could see depth changes that do not match dredging plans. All of this is made harder by climate swings. More intense storms and rapid lake level drops and rises load and unload the crust faster. That gives the new cracks fresh pressure cycles to work with. Ecologists watching the deep parts of the lake added another concern. Fissures can become new habitats. Microbes that feed on methane live in such sites. They form mats that support unique food webs. That sounds positive until the new web takes oxygen from nearby waters and stresses fish that local economies need. Add in the chance of algae blooms from altered nutrient flow, and the picture gets complex fast. Every piece of the lake system is tied to every other piece. Change the bed, and in time you change the fish, the beaches, the intake pipes, and the people who depend on them. City officials want to secure water. Fisheries want to secure spawning zones. Power companies want to secure coolant flows. Homeowners want stable shorelines. The science teams want more instruments on the lakebed to see what is really happening, but that costs money and time. Meanwhile, the fractures do not wait. They widen bit by bit under hundreds of feet of water where cameras cannot watch all day. That is why the USGS called for round-the-clock monitoring and why emergency planners asked a harder question. If a slow split turns sudden, how much warning will anyone actually get? Signs the crust is waking up. Seismologists around the Great Lakes keep long records of tiny quakes. Most of the time they are rare and scattered. After the Lake Michigan cracks were mapped, that pattern changed. Clusters of microquakes began to show up under the central basin and along the line of the oldest rift. None of them could knock a glass off a shelf, but together they drew a picture of rock that was slipping in small bursts. This is how rifting begins in other parts of the world. First, the rock stretches. Then it breaks in narrow zones. Then the breaks link. Only in active zones, the steps can happen in months. In a place like Lake Michigan, the steps should take centuries. Yet the rate of events in 2025 looked more like a young rift than a dead one. That made researchers review old reports from the 18 and 1900s about odd shaking near the lake. When those events were plotted on modern maps, many sat right on top of the new fissure system. That suggests this part of the continent has tried to move before, but never had the instruments in place to catch the full story. Add in new electromagnetic readings that show the stress field around the basin changing shape, and the word reactivation no longer sounds dramatic, it sounds accurate. If a buried rift is waking, even slowly, then more cracks, more gas vents, and more ground warping are likely. That does not mean the lake will split in two in our lifetime. It does mean the background hazard level for the whole region just went up. Insurance models, building codes, pipeline routes, and even wind farm plans will have to adjust. Cities that thought of earthquakes as a West Coast problem will have to plan drills. People do not love hearing that message, but it is better than being surprised by a larger event. Seismologists often say the Earth gives warnings. Here it is giving them under a veil of water. Some groups have asked if the current cracking could trigger slides on the lake floor. Underwater landslides are rare here, but when loose sediment sits on a slope and the base shifts, it can drop. If that happens near a shore intake, the rush of mud can clog pipes. That is another reason the monitoring must grow. Scientists in Canada and the United States have proposed a joint task force because the Great Lakes are shared waters. A moving lakebed does not stop at a state line. But coordination takes time, and the lake is already moving. Early trials with new buoys, seismometers and thermal cameras are already in place to give constant readings. More units will follow this year, across agencies. How much time do the people living around it really have before plans must become action? People, policy, and a moving lake. News of a red alert under Lake Michigan spread fast. Some stations kept the tone measured. Others spoke like a disaster was near. Residents along the shore wanted simple answers. Will the water stay safe? Will the beaches stay open? Will homes on bluffs feel any shaking? Scientists could not promise much beyond this. The lakebed is changing, and it will keep changing. That answer is true, but it is not comforting. City leaders in Chicago, Milwaukee, Green Bay, and smaller towns called for daily briefings. They asked when to close parts of the lake to shipping, how to protect intake pipes if mud slides, and what to tell people who saw videos of cracks on social media. Federal agencies promised more instruments and joint task forces, but people on the ground wanted to know who was in charge if things got worse. The Great Lakes touch 4 states and 1 country. Each has its own rules. That makes any unified response slow. Tribal nations around the lakes added another needed voice. Their stories tell of water and land as living beings that can wake, rest, or send warnings. For them, the cracks were not a surprise. They were a sign to respect and to study. Scientists listened because older oral histories sometimes match what new instruments find. Several elders described strange ground sounds and water shifts in the past that fit with historic quake reports. Those memories helped point researchers to areas worth watching now. Alongside the serious planning came rumor. Online posts claimed the lake could drain, that a volcano sat below it, or that secret tunnels were breaking. None of that is supported by field data. Still, rumors spread faster than updates. That is why outreach teams began to release graphics and short videos showing what was actually seen under the water. They showed a crack network, slow uplift near the west shore, gas bubbles and heat patches. No drain holes, no sudden sink. The goal was to make the invisible changes real without causing panic. Schools and universities began adding lessons on intraplate quakes and glacial rebound so students would know this is normal Earth behavior, just happening in a place people forgot could move. Emergency managers also pushed for families to have the same go bags and plans that West Coast residents use. Prepared people need fewer last-minute rescues. With the lake floor active, that is a smart habit. But one question began to hang over every meeting. If the cracks widen into faults and the faults start to link toward land, who decides which towns get help first and who has to wait? Budget talks in state capitals are already tight, and adding underwater monitoring, shoreline reinforcement, and emergency drills will cost millions. Some lawmakers want to wait for more proof. Scientists warn that waiting is the risk. The lake is giving early signals. Will leaders act while the changes are small, or will they wait until the water itself forces the hard choice? What comes next beneath the water? With instruments now ringing the lake, the next phase is verification. Scientists must test whether the first readings were spikes or the start of a trend. That means repeating seismic runs, repeating sonar passes, taking more sediment cores, and watching gas flow over months. If the crack edges stay sharp and the warm spots stay warm, then the process is active. If they soften, the lake may be moving toward a new balance. Either way, the record will be priceless. A living rift under a cold freshwater lake is rare. It can teach us how old scars in continents wake up, how water loads help or hurt that process, and how human projects along the shore feed back into it. Engineers will use that data to design flexible intakes, tunnels with more joints, and pipelines with strain sensors built in. Ecologists will use it to see how deep life responds to new vents. Planners will use it to decide where not to build. The public will use it to judge whether warnings were honest. Because once trust is lost on a lake everyone depends on, it is hard to win back. Another likely step is international study. Canada shares these waters. European and Asian labs have tools for imaging deep rock underwater. A joint expedition could map the entire fracture system in high resolution, not just the parts near American sensors. That would show whether the cracks are one local issue or part of a bigger pool across the Great Lakes Basin. If they are part of a bigger pool, then Superior, Huron, and even connected groundwater systems could feel it too. That would make this not just a Michigan story, but a continental one. It would also bring in energy and mining interests who watch deep heat and mineral roots. Some vents could host rare earth elements. That will tempt companies to explore. Any such work must balance research with protection. We are talking about the core water source for millions. The last thing anyone wants is drilling or heavy gear to widen a crack or cloud an intake. So the tests have to be open, slow, and shared. The lake is loud in scientific terms right now. Reading it right will take patience, even as the news cycle begs for instant answers. But if the floor is splitting, even in slow motion, then the people on shore deserve to know in plain words what is happening below. That choice is the real hard test. It is easy to film deep cracks and hard to change budgets, codes, and habits. Lakes remember pressure for ages. Humans prefer short memories. This time, the choice to remember will decide how much of the shoreline stays safe, how much water stays clean, and how ready we are when the next pulse comes up from the living rock. Will we face that truth while it is still only lines in the mud, or will we wait until the lake itself rises to tell us? You have now seen how a quiet lake can turn into a moving map. Tell us in the comments what part of this story worries you most. Like and subscribe so we can keep tracking the sensors and the science together. The lake is changing. Let us not be the last to notice. Share this with someone who still thinks the Midwest never shakes. Stay ready, stay curious.